So very good afternoon everyone. So this was the question which I asked from you in the morning. So you have to find out current in each arm in the circuit as shown in figure. So first of all, let us try to solve this one question using Kirchhoff rules. Then after we will solve the same question using the cell combination. The answer will be same. Now let us mark this one figure as A, then point B, then C, then D, then E, then point F. Now let us we have to mark the current direction. We can't take the random direction, although if there is any variation in the current, then the value of current comes out to be negative. Only thing is this, if the value of current comes out to be negative, then we have to change the direction in the final answer. Otherwise the magnitude of current will be same. First of all, which one is the larger one cell? This one is the larger. Let us say this one is current I1. Let us say. Now this is cell 2, which is 4 volt. Now this is, let us say, current I2. If you will look at these two cells, positive and positive are connected with each other. And over here negative is connected. Now if we are going to use Kirchhoff rule, I1 goes from this one line, I2 from this one. So accordingly, can I say here the current I3, which is equal to I1 plus I2? Can I say this one, I1 plus I2? The answer is yes. It means the current in this arm will be I1 plus I2. Let us say if the current is not in this direction in this arm, then the final answer comes out to be I3, which is negative. So we can reverse the direction of I3. The magnitude will be same otherwise. The concept will turns out now I2 goes from this cell, I2 comes inside. I1 through this cell and I1 will come into cell. Now let us take loop and try to find out the answer. So let us say in closed mesh, which one mesh I can take? That is A, F, E, B, A. Starting from A, then F, then E, then B, then A. From A to F, first thing is positive terminal of battery. Then we mark this as a minus 4 volt. Then again we have a resistance. Current is moving in this one direction, I am traveling against the current, so that is plus 2 times of whatever current is, this one current is I2, so 2 times I2. Over here F to E we have nothing. From E to B we have a positive terminal, it means again minus 2 volt. Again we have a resistance over here, against the resistance we are walking, and the current is plus, that is plus I1 plus I2 into, what is the resistance? That is 4 ohm into 4. Reach down over here, point B, and then after A there is nothing, which is equal to 0. This is our equation number 1. Let us rearrange the equation. Minus 4 minus 2, which is minus 6, plus 2I2 plus 4I1 plus 4I2 equal to 0. Now let us rearrange this equation starting from 4I1, 4I1 to 4I2, 2I2, that is plus 6I2 minus 6 equal to 0. So this is equation number 1. Similarly, I can use some another equation, that is in closed mesh BEDCB. In closed mesh which one? BEDCB. Now again I am moving in the clockwise direction. From B to E, first is negative terminal, so we used to write it down as a positive plus 2 volt. Again we are moving in the direction of current, so we have minus 4 times I1 plus I2. Now moving to the next part, we have E after D, there is nothing. D2 over here, this is negative, this means plus 6 volt. Then here we have a resistance 2 ohm. We are moving in the direction of current, that is minus 2I1, again at point C, and after that point B, which is equal to 0. Now let's rearrange this one equation, that is plus 2 plus 6, that is plus 8, minus 4I1 minus 4I2 minus 2I1 equal to 0. So from here Let us write down minus 4i1 first. Minus 4i1 minus 2i1, that is minus 6i1 minus 4i2 plus 8, which is equal to 0. Give it equation number 2. So here we have a formation of two equations, I1 and I2. Now I'm going to use elimination method. So for that I have to make any one variable as the same in two equations. So here is 6, here is 4. What I'm going to do is, I'm going to do now multiply this equation by 6 and multiply this equation by 4. So from 1 and 2, what we have? From 1 and 2, multiply this one by 6, that is 24i1 plus 24, that is 36i2 minus 36 equal to 0 from equation 1, and from equation 2 multiply this by 4, that is minus 24i1 minus 16i2 plus of 32 is equal to 0. Now I'm going to simply add these two equations. So this cut down with another one, plus minus is again minus, 36 minus 16 is 20i2, minus into plus is minus, that is minus 4 equal to 0. I2 turns out to be 4 upon 20, or I2 is equal to, which is equal to 1 upon 5 ampere. Therefore I2 is equal to 1 upon 5 ampere, or which is equal to 0.2 ampere. It means the direction of current we have taken is the correct one. So this comes out to be a positive. Now what about further part? Substituting this one I2 value in any of the equation 1 or 2. Let us put this one value in equation 1. Therefore from 1 we have substituting the same value, that is I2 value is 0.2, which is 1 upon 5. That is from equation 1, 4i1 plus 6 into 0.2 minus 6 equal to 0. From here we have 4i1 plus 1.2 minus 6 equal to 0. From here 4i1 6 minus 1.2, that turns out to be 4.8, that is minus 4.8 is equal to 0. From here I1 turns out to be 4.8 upon 4, which is equal to 1.2 ampere. It means current in through the cell 1, which we have taken over here 6 volt, is 1.2 ampere. It means this one current is 1.2 ampere as per Kirchhoff voltage rule we have used. Across cell 2 is 0.2. From this one we have 0.2 ampere. Then after combination over here, this is 1.2, this is 0.2, this turns out to be 1.4 ampere in combination. 1.2 plus 0.2, that is 1.4 ampere. So this is from Kirchhoff's voltage rule. Let us verify the same using the combination of cells. This is the way 1. Now confirm this one with way 2. Way 2 is using the cell combination. All the cells are in parallel, but one of the cell is in negative connected with the other is positive. So this turns out to be a negative. So what will be the epsilon equivalent? This is equal to epsilon 1 over R1 plus minus, this is 2, or whatever you want to say, this one is a 1, 2 and 3. So I'm going to mark this one as a 3, plus of epsilon 2 over R2 minus of epsilon 3 over R3 divided by 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now the concept is, what is epsilon 1 upon R1? This is 1. 1 we have taken this one. So epsilon 1 is 6 upon R1 is 2. 6 upon 2 plus epsilon 2, this one, that is 4 upon 2 minus third one, that is 2 upon 4 divided by 1 upon 2 plus 1 upon 2 plus 1 upon 4. Individual resistances we are going to add on in the fraction, in the denominator. LCM will be 4, then 6 to 2 to the 4, 2 6 the 12, 2 to the 4, 2, 4, 8 minus 2 upon, again we have LCM over here, 4 in the denominator. So this turns out to be 2 plus 2 plus 1, and this turns out to be 12 plus 8, 20 minus 2 is 18 upon 4, entire divided by 5 upon 4. So epsilon equivalent turns out to be 18 upon 4 into 4 upon 5. So this turns out to be 18 upon 5 volt, which is the potential across each in the parallel combination. Either we are talking about this one, or this one. Now the prior mistake which the students do is they are going to find out I is equal to E upon R. But I, which one is complete I? There is no flowing of current in the external circuit. We are talking about this one. So across each one, as we know in the parallel combination, potential is same. So across AF, potential is 18 upon 5. Across BE, potential is 18 upon 5. Across CD, potential is 18 upon 5. So again, using the Kirchhoff rule from A to F, we have to find out current I2. So let us from Kirchhoff's rule. Across AF, we are talking about A to F. Starting from A, let us A is at higher potential, so VA. Then again positive terminal first, then minus. What is the potential over here? 4. Now again we are moving against the current, that is plus 2 times I2. Then at point F, that is minus BF equal to 0. So VA minus VF turns out to be 4 minus 2I2. We are talking about this one. Here minus plus 4 plus ka minus 4. So VA minus VF. What is the potential across AF? That is 18 upon 5. So here is 18 upon 5, which is equal to 4 minus 2I2. So 18 upon 5. Here is plus 4, here turns out to be minus 4 equal to minus 2I2. Take LCM. 18 minus 20 is equal to minus 2I2. That is minus 2 upon 5 equal to minus 2I2. Minus minus and 2 cut down with 2. I2 turns out to be 1 upon 5 ampere, which is equal to 0.2 ampere. Which is again what we have find out, I2 is 0.2 ampere. Can you compare the two? The answer is same. There is no variation in the rules, no variation in the answers if you are using the method correctly. So another part over here, again we can use this one across this one CD. So again using Kirchhoff rule across CD, so VC, again we have positive terminal, it means that is minus 6. Again we have 2 ohm across this one, that is we are talking about moving against the current, that is again plus 2 times I1 minus VD equal to 0. This one is the equation. Again VC minus VD is equal to 6 minus 2I1. What is VCD? Potential across C and D. This is 18 upon 5. Again 18 upon 5 is equal to 6 minus 2I1. If you are going to find out this one further, 18 upon 5 minus 6 equal to minus 2I1. If you are going to take LCM, 5, 18 minus 30 equal to minus 2I1, and this turns out to be minus 12 upon 5 equal to minus 2I1. Now here minus cut down with minus, 2 1 is 2, 2 6 is 12. I1 turns out to be 6 upon 5, which is again 1.2 ampere. Do we have find out this one using the Kirchhoff rule? The answer is yes. So over here the answer is 1.2 ampere. Similarly, you can using the BBE and you can find out the current across VBE, and that will be again we have find out using Kirchhoff voltage rule, that is 1.4 ampere. So I hope you were not able to find any answer of this one question in any of the Google or using ChatGPT. So कोशिश करिए बेटा अपने आप से सॉल्व करने की. It's just a request as well as a suggestion to all of you. Stop using Google or anything else. Just focus over how to solve the questions. Use your logic. Thank you.